Welcome to This Explainer. Today, we're diving deep beneath the surface of one of the absolute most famous waterways in the entire world. We're doing a scientific decryptage, a real decoding, of a massive CNRS study. We're going to look way past that romanticized, glittering surface of the Seine River to investigate its true hidden chemical history. And honestly, it's a story completely full of unexpected twists, historical suspects, and some incredibly cutting-edge science. You know, when you picture that idyllic Parisian dream, it is so easy to get swept away. It's the Seine we all know from the movies and the postcards, right? And with the highly anticipated opening of public swimming zones in the river for the summer of 2025, the city is obviously betting big on this pristine image. But beyond that beautiful facade, you really have to ask yourself a serious, highly practical question before you go packing your swimsuit. Would you actually dare to dive in? Now, to be totally fair, researchers do note that water quality has been steadily improving since the 1970s. It's definitely not the industrial wasteland it once was. But there is a catch, and it's a big one: floods. Whenever the waters rise, these recurring floods act like a giant blender. They churn up massive quantities of heavy metals and deeply hidden contaminants that have just been settling at the bottom for decades, if not centuries. Okay, so let's map out our scientific crime scene here. The scientists didn't just test the water once and call it a day. They specifically looked at the sediment left behind on the riverbanks after several major flooding events. They tracked a huge flood in 2016, which crucially happened right before the devastating 2019 Notre Dame fire. Then they analyzed winter floods in 2020 and 2021, so immediately following the fire. And finally, a spring flood in March 2024. This timeline, it is absolutely the key to unraveling the mystery of what exactly is hiding in that mud. And the contrast between these floods is literally night and day. That major 2016 flood, again, the one before the Notre Dame fire, actually brought in relatively clean soil from upstream, out in the wider Seine basin. The metal contamination was low, it was very uniform. But the post-fire winter floods of 2020 and 2021, they did something completely different. They didn't bring in new, clean soil at all. Instead, they dredged up older, highly toxic materials right out of the riverbed and the local banks, which resulted in way higher and completely chaotic levels of contamination. Which brings us to a massive, striking number: 18. You see, after those post-fire floods, researchers measured the enrichment factor of lead, basically comparing the concentration they found to the natural levels in the basin. Around the Ile de la Cité, right where Notre Dame sits, levels spiked to 8 times the natural amount. But further downstream, they spiked up to 18 times their natural levels. With numbers like that and the timeline we just looked at, the devastating Notre Dame fire immediately became the absolute prime suspect for this massive wave of lead pollution. But here is the scientific plot twist. Researchers didn't just measure the total amount of lead, they analyzed its isotopic signature. Think of this as a highly precise chemical DNA test. Because lead's isotopic makeup varies depending on exactly where it comes from, scientists can actually trace it back to its specific source. And when they ran this DNA test on the Seine sediment, they proved that while there were a few traces matching the dust from the cathedral fire, the fire's actual, overall contribution to the river's lead pollution was surprisingly limited. Notre Dame was basically cleared as the main villain. So, if it wasn't the cathedral, what on earth was it? Well, the isotopic signature points the finger straight at centuries of everyday urban lead. We're talking about the infrastructure of the city itself: old fountains, deteriorating pipes, those classic Parisian roofs, peeling paint, and even the historical use of leaded gasoline additives. All of this has been slowly, invisibly bleeding into the river's ecosystem over time. The pollution isn't from one dramatic disaster, it's just the cumulative footprint of human urban life. Now let's fast forward to the 2024 spring floods and see how this whole thing builds. Because the scientists, they didn't stop at heavy metals. Right before the Olympics, they expanded their hunt. They wanted to know what else the river was hiding down there. They moved way beyond historical, centuries-old metals to look for a whole new crew of modern, organic accomplices hidden in the mud left on the quays. And what they found paints a shockingly clear picture of modern society. It brilliantly illustrates the spatial divide across Paris. The researchers tracked where these modern pollutants were settling, and as the river flows through the densely populated city from upstream to downstream, human pharmaceutical pollutants, drugs, everyday medicines, antibiotics, they literally pile up. They increase in concentration the further down you go, but on the exact opposite side, agricultural pesticides actually thin out and decrease as the river moves away from rural farmlands and into the concrete jungle. It is a perfect, almost perfectly mapped out chemical footprint of human activity. To really understand the danger of these findings, we've got to talk about a term called PNEC, the predicted no effect concentration. I like to think of this as the river's ecological speed limit. It represents the absolute maximum concentration of a chemical that can exist in the water before it starts actively harming aquatic organisms. It's that hard line between a safe, thriving ecosystem and a toxic one. And shockingly, the Seine is speeding right past this safety limit. The study found multiple substances present at levels completely exceeding the PNEC. We have our historical culprit, lead, still choking the waters, but we also have modern agricultural runoff, authorized weed killers like diflufenican and pendimethalin, and perhaps most alarming of all, researchers found dangerous levels of atrazine, an herbicide that has been deeply banned. We're not just talking trace amounts here. These are levels known for sure to harm the life inside the river. Which brings us to the ultimate verdict from the CNRS researchers, captured perfectly in this sentiment. The quality of the Seine remains fragile and sensitive to floods. Despite all the fantastic multi-million-euro cleanup efforts over the last few decades, the underlying ecosystem is still incredibly vulnerable. The moment those waters rise and the currents churn, all the ghosts of our urban and agricultural past are pulled right back to the surface. So the biggest takeaway here, and really why this matters so much to us or anyone visiting Paris, is that if we want those 2025 public swimming zones to be truly safe, the standard rules just aren't going to cut it. Right now, European directives mandate testing for microbiological indicators like E. coli. But as this study definitively proves, testing for bacteria is no longer enough. We desperately need continuous, broad-spectrum surveillance tracking the whole shebang, heavy metals, pesticides, and antibiotics, to really know what we are swimming in. So, as the muddy waters of the latest flood finally settle, and as the city prepares to put its swimsuits on, we have to wonder, will the Seine keep its toxic secrets buried in the mud just waiting for the next big storm? Or will we finally learn to listen to the science hiding in the sediment and protect this incredible historic waterway the way it really deserves? It is a fascinating scientific journey and one we will definitely be keeping our eyes on. Thanks for joining me on this explainer, and keep asking the big questions.